So today what I want to do is we talked about one strategy of solving a system, and that's graphing. And you saw some inherent flaws with it. What if they give you variables that aren't x and y? Then we get a little confused. What if the graph is way up here and I drew a graph this big? I'm going to have to continue and I may go off the paper, which of course doesn't work, and I have to redo it. It may give you rational coordinates, not integer coordinates. And so how do you estimate what that is? So there's a time and a place when I do graphing using, solving a system using graphing. For the rest of this week, you're going to learn different techniques to use, but each technique has a particular situation in which it's best to use that particular technique. So the one I want to share with you today is how you solve a system using something called substitution. Okay, so that's our objective today, is understand how to solve a system using substitution. Okay? So what I'm going to do is let's go through one problem together, and then we'll go back and we'll write down some steps we need to follow, and then we'll do two more, okay? So let's start with directions are just going to say solve. And we've got x equals 3y, and the other equation is 2x plus 4y equals 20. So what do you guys know about the word substitution? What does that tell us that we get to do? Brian?
Just plug it in.
Okay, so we're going to take something and plug it in someplace else. So let's look at that equation. Do you see something that we could plug in somewhere else? Ian? Where could the 20 get plugged in? What else equals 20? Okay, that's true, but that's not what substitution is. That's you solving. Okay, substitution is taking something and replacing it with what it equals from somewhere else. Okay, Serena?
You could plug in the 2x plus 4, you can plug in 3y for the x.
So if you notice over here, it says x is equal to 3y. So what that says is when I see x, it also means the same thing as 3y. So I could substitute 3y in for that x. That's what substitution is all about. Something, single value, that I can plug in another equation. So what my new equation now becomes is 2 times the quantity 3y, and then I write out the rest of that second equation, plus 4y equals 20. So I multiply and I get 6y plus 4y equals 20. I get 10y equals 20. I divide by 10 and I get y equals 2. So for my solution, I have half of it. I've got the y coordinate. How would I figure out the x coordinate? What would I do at that point? Brian?
You take the y and you plug it into the first one?
Yeah. Do I have to go back to the first one?
No.
The answer is it's actually a good choice because what am I solving for? X. And in that equation, x is by itself. The other thing that it's good to plug it into the other equation is what if I made a mistake plugging it into the second equation when I solve the second equation? So it's always good to involve both equations. So I'm going to take this guy and I'm going to substitute him into this equation. So now that gives me x equals 3 times the y value, and the y value is 2. And I get x equals 6. So that looks like that's my solution. Now I can check it and make sure that it satisfies both equations, which is always a good thing to do. So is 6 equal to 3 times 2? And the answer is yes. So it does satisfy this first equation. So let's try the second one. Is 2 times 6 plus 4 times 2 equal to 20. So I get 12 plus 8, and I get 20 equals 20. So it satisfies this equation as well. So what that verifies is, yes, that is the solution to the system. Okay? Maggie?
And so you just stop there.
You're done. That's all you're asking is what's the solution. Okay? So that's something that we're working on. Okay? Now, look at those two original equations. Is there something about those two original equations that would make substitution the logical choice for this problem? Do you notice something, Miles?
One equation has the x value all by itself, so there's kind of like there's kind of you have the x and the y value, and the x value is 1.
Okay, well, you're going with x. He's by himself. That's actually it. Notice that on the first equation, one variable is all by itself. It has no coefficient. So it's really easy to take its value, 3y, and substitute it in for the x in the other equation. That's what I want when I do substitution, is I want one of my equations to have one variable alone with no coefficient. Okay? When I see that, that's when I tend to use this technique of substitution. Okay? So let's write down some steps. Now, there are ways to alter an equation to have one variable by itself, and you can use that idea as well. Brian?
This is probably not a really good thing to do, but if, say, the first one was 2x equals 3y, could you just take out the 2x from the second equation and then plug in whatever is?
If you have, that's something else you can try to do, and that's another technique we're going to talk about later this week, is altering one or both equations so that you can find a match, and then you could either do substitution or there's other strategies that we can use. But again, I want to do the most efficient method for each situation, and most efficient requires fewer steps. So that would require more steps. If I multiplied both sides of that first equation by 2, I would get 2x equals 6y. Then I could replace the 2x with 6y. But I had to do an extra step that I didn't do when I did it this way. Okay? So yeah, there's lots of options. There's lots of options. But what I'm trying to get you guys to do is look at what am I given, and of the options, so by the end of this week, you'll be a better expert, which of my techniques is going to be the fastest way to solve this problem. Okay? Jason? Can you put your hand down so I can hear you? Can I? Oh, yeah, I told you we were going to do this first, write down some strategies, and then go and do 2 more practice problems. Okay? So let's talk about some. So the process for substitution. First thing I look for is find one equation that has one variable with no coefficient. Ideally, that variable that has no coefficient is already by itself. So like we had x equals 2y. If I had x plus 2y equals 3, what I could do is get x alone by subtracting whatever from both sides. Okay? I can alter an equation that has a variable with no coefficient to get him alone. So I can do an extra step if I want to make it substitution. Now please understand, throughout this week, each night you're being asked to do a particular strategy. So tomorrow night you can't use substitution. Okay? Thursday, you can't use substitution, all right? Because you need to practice each of the techniques separately. But then when it comes to solving, from that point on, it's your choice. What's the strategy you're going to use, okay? So find one equation that has one variable with no coefficient. If it isn't alone on one side of the equation, solve until it is alone. We should call this the lonely technique. You want to get this guy lonely and then make him disappear and get replaced with his alter ego. Miles.
Well, which of the questions on your homework have it already alone?
Yeah, I would say pretty much every one of them, okay? It's been a year since I've done this homework assignment, so I can't remember exactly, but pretty much. Okay, so now what we're going to do is substitute the expression that equals that variable, and here's the key. You cannot substitute it back into itself, into the, and I'm going to yell at you a little bit, other equation. So we take from one, we put to another. We cannot take from one and put it back into itself. If we do that, we're going to get an answer that's always going to be true, and that's not going to help us solve, okay? So what you're basically doing at this point is you've taken a two-variable equation, and now it's all one variable, and we're back to what we did in the very beginning of equations. So now we're going to solve for the remaining variable. And you're going to get that variable equals some number, okay? Now, once we have one of the variables, we have half of our solution. Now we need to figure out the other half, so we're going to substitute this value, and here comes keyword, I'll put it again boldly, this value into either, it can be either, I like to go back to the one I didn't do, but the key is original. So you're not going to go back to any equation. There's an L stuck over here. Let me do darker. You're not going to go back to an equation that you've done math to, because what if you've made a mistake? So you want to go back to the original equation. The original equation. And solve for the remaining variable. You're going to write the ordered pair, or the solution as an ordered pair. Oops. And I'm going to write alpha order here. What does alpha order mean? Alphabetical order, okay? Alpha.
The word is original
Either. And then check, and it must satisfy both original equations. Okay, so again, must satisfy both original equations. All right, so let's do a couple more examples. We're back to solve, and for us, it's finding a solution, and a solution in a system is an ordered pair. So let's do one with not x's and y's, because I do see there are a couple on the homework tonight. So we have 4a minus 3c equals 23, and a equals 1 minus 4c. Okay, so we're looking for an equation that has a variable without a coefficient. Do we have that situation? Yeah. Do you notice? We've got a, and it doesn't have a coefficient. What's even better, though? It's already alone, right? A is all by itself. So what that says is take the expression that equals a, which is the 1 minus 4c, and you're going to substitute it back in for a into the other equation. I'm not going to substitute in 1 minus 4c for a in the same equation that I'm taking it from. That's not going to work for us. So here's what my equation now looks like. I have 4, and then times the new a value, which is that 1 minus 4c, minus 3c equals 23. So what I've done is I've taken a two-variable equation and I now only have one variable, and I can solve one variable equations. So I distribute. 4 times 1 is 4. 4 times negative 4c is negative 16c. There's a minus 3c on the outside, so he gets written in. On the left, I have 3 terms, so I have to look for like terms, and I've got them right here. My c's are the like terms. So I'm not changing the 4. Now, because I'm on the same side, I'm going to do the same math. So I have a negative 16c minus a 3c. Signs are the same, so I add, and I get a negative 19c. That equals 23. Now I start doing opposite operations to get that c alone. So I'm just practicing what we learned before. We were practicing earlier in the last quarter about equations. So I get negative 19c equals 19. Last step is to divide both sides by negative 19. By the way, is it possible to get coordinates that are fractions or decimals? Are we always going to get integer values? Now, we're not guaranteed integers. Most likely, most of them are going to be that way because, again, you're learning something new, so they try to be nice to you, except for if we're in the new online book, then they're mean to you from the get-go, and they give you evil, evil things. So right now, I have half. I believe I have half of my answers. So I can put over here, and again, I'm going to go alpha order, so that's going to be like the y value. All right, so now I'm going to take this and I'm going to plug it back into either original equation to figure out what A equals. So of the two equations, which one is going to be fastest for me to figure out what A equals? The second one, right? Because it already has A alone. So that's going to be easy. So we have A equals 1 minus 4, and now we're going to substitute in the value of C, which is that negative 1. And we just solve. So we have A equals 1, negative 4 times negative 1 is positive 4, and we get A equals 5. So we plug that into our solution, and we believe the answer is going to be 5, negative 1. So now I'm going to do a check. So is 4 times the A value 5 minus 3 times the C value negative 1 equal to 23? So I get 20. Two negatives make a positive, plus 3 equals 23, and I get 23 equals 23. So that ordered pair satisfies the first equation. Does it satisfy the second one? Is 5 equal to 1 minus 4 times the quantity, negative 1. So is 5 equal to 1, negative times a negative is a positive 4, and I get 5 equals 5. So I have actually satisfied both equations, which verifies that, yes, 5, negative 1 is my solution. Jacob.
Where'd you get negative 1?
Where did I get what?
Negative 1. For when you're solving.
C equals negative 1. 19 divided by negative 19.
Okay.
Signs are different. I'm going to get a negative answer. Okay.
But, like, why is it in the other equation?
Because I'm substituting that value for C into the second equation,
Okay.
and that's how I figure out what the A is.
Oh, okay.
Okay? Yeah, we substitute. We get to do a lot of substitution. And we will substitute throughout all of these because the second half of every problem is substituting the answer we get into one of the original equations to figure out the other coordinate. All right, let's do one more. Ready? Uno más. Oops. So we have 4x plus 3y equals 2, and the other equation is negative 2x plus y equals 4. Okay. Dang. The last two are kind of nice. They gave me a variable all by itself. So now we have to look a little harder. Is there any variable in those two equations that has no coefficient?
Yeah.
Patrick?
Y in the second.
Y in the second one. So let's get y alone. How? Let's add 2x to both sides. So sometimes we have to do a teeny bit of work, but that will really help us solve this problem. Now I've got y all by itself. So I have an expression, 2x plus 4, that has the same value as y. So I'm going to substitute it back into the other equation for the y value. So I get 4x plus 3 times the quantity, 2x plus 4, equals 2. And then I just start solving. When I distribute, I get 3 times 2x is 6x, 3 times 4 is 12. I look on the left side for any like terms, since I have 3 terms, and it's my x's are like terms. So I'm going to add them together. 4x plus 6x is 10x. I always do this first. If I do it separately, it just is a mess. You guys got to learn how to be efficient. All right, now I want to get the x alone, so to do that, I'm going to go ahead and subtract 12 from both sides. And I get 10x is equal to, let's see, signs are different. I'm going to subtract bigger numbers negative, so my result is negative, and 12 take away 2 is 10. And then I'm going to divide both sides by 10 to get the x completely alone, and I get x equals negative 1. So, in my ordered pair, x, y, I think the x is negative 1. Now I'm going to plug this back into either original equation, and solve for y. So of the 2 equations I have, which one would probably be the easier one to substitute x into to figure out the y value? Yeah, and why the second one? There's a good reason for it. Connor?
Because the y's alone.
Because of y's alone. So I'm going to have to do less work to figure out y on this one. Okay? So this gives me negative 2 times the x value, which is negative 1, plus the y value, equals 4. 2 negatives multiply to give me a positive, so I get 2 plus y equals 4. Subtract 2 from both sides, and I get y equals 2. So that becomes the y coordinate of my solution. So now I'm going to check and see if 4 times the x value plus 3 times the y value, does that actually equal 2? So different signs make a negative product. I get negative 4 plus positive 6. Does that equal 2? Signs are different. I'm going to subtract bigger numbers positive. 6 take away 4 is 2. And I get 2 equals 2. So it satisfies the first equation. Let's check the second one. Is negative 2 times the x value of negative 1 plus the y value of 2, does that actually equal 4? 2 negatives multiply to give me a positive, so I get 2 plus 2 is 4, and 4 equals 4. So I satisfied both original equations, which means the answer needs to be negative 1, 2. Okay? Notice ordered pairs have parentheses. The terms are written alphabetically, and there's a comma between them.